Hello and welcome back to another episode of Math with Zone. Today, we're going to be finding all zeros of a polynomial. All right? And for that, hopefully you have a graphing calculator because that will definitely expedite the process. But if you don't, there are other ways to do it called guessing and checking. All right? But there are ways to make the guessing and checking quicker, which is finding the possible rational zeros, which are the real ones, not the imaginary or complex ones. And you get the rational zeros, the possibilities, which we call the PRZs, by taking plus or minus the factors of the last term and dividing by the factors of the first term. Okay, so it's factors of the last term divided by factors of the first term. The factors of the last term in this case are 4. We don't worry about the fact that it's negative. So we would have 4, 2, and 1 for the factors of 4 over the factors of 9. We don't worry about the fact that it's negative. So this would be 1, 9, and 3. The issue is that you have to put all of these over all of these. So we're going to have 4 over 1, 2 over 1, 1 over 1. So we have plus or minus 4 over 1, plus or minus 2 over 1, plus or minus 1 over 1. And I know we don't need to write the ones. We also have plus or minus 4 over 9, plus or minus 4 over 3, and plus or minus 2 over 9, and plus or minus 2 over 3. All the combinations of all of those. All right? So let's make sure I didn't miss any. So we got 4 over 1, 2 over 1, 1 over 1. We got 4 over 9. We got 4 over 3. We got 2 over 9 and 2 over 3, and we got 1 over 9 and 1 over 3. Did I include the 1 over 3? I don't think I did. I don't think I included the 1 over 9 and the 1 over 3 with pluses or minuses. So be careful not to miss any. Now the purpose of that will be to find the actual zeros. You would be using these as a possibility to start as like a baseline to guess. All right? But you're probably going to end up guessing with the ones in front, the 4, the 2, and the 1. All right? Positive and negative. Let's do another one. We got the factors of 6, which are 6, 2, 1, and 3, all over the factors of 4, which are 4, 1, and 2. So I'm going to put all of them over 1. So that would be plus or minus, let's box the previous answer, plus or minus 6, plus or minus 2, plus or minus 1, plus or minus 3. And a lot of times you'll see people be lazy and just put the plus or minus in front of all of these. That's the lazy way. Technically, you're supposed to write 6 and negative 6 and things like that. So all of those were over 1. Now I'm going to put them all over 2. So this would be 6 over 2. This would be 2 over 2. This would be 1 over 2 and 3 over 2. Some of those are duplicates. 6 divided by 2 is just 3, so we don't need to write it twice. 2 over 2 is just 1, so we don't need to write that twice. 1 over 2 and 3 over 2 are unique, so they stay. All right, so all of those were over 1. All of those are over 2. Now let's put them all over 4. We got plus or minus 6 over 4. We got plus or minus 2 over 4, 1 over 4, and 3 over 4. Are any of those duplicates? The 2 over 4 is the same thing as 1/2. 6 over 4 is the same thing as 3 over 2. So technically you do not need those. And whatever is remaining would be your answer. Okay? And if you're welcome to write the duplicates, but you don't want to do it twice if you don't need to. Now, we're going to be determining all the zeros for the function. So in order to determine all the zeros for the function, notice how I have a lot of space here. It could take a while. You always need to get whatever you're provided with, an x to the third in this case, down to an x squared, because once you get it to an x squared, you can factor, hopefully, or use the quadratic formula. Guaranteed. So what you should do is figure out what are the possibilities given this problem. And knowing that it is an 8 and a 1 here, the PRZs are just 1 over 1, 2 over 1, 4 over 1, and 8. Now, given all of those choices, you should always, no matter what the possibilities are, start with 1 and negative 1, and we are going to divide by that. So I'm going to start by dividing by a positive 1. We have these numbers right here, 1, negative 10, and negative 8, and we're just going to hope that 1 works, because if anything, 1 can divide by most, like you can divide most things by 1. We bring a number down 1. We multiply, we get 1. We add, we get 0. Multiply, we get 0. We add, we get negative 10. We multiply, we get negative 10, and we get mad because it didn't divide by positive 1. Well, maybe negative 1 will work, or maybe 2 would work. Okay, so you could keep going through the guesses. If you have a graphing calculator, then you can alleviate the guesswork. But if you don't, you're going to have to just keep guessing. We tried 1, it didn't work. You would have to try 2. We would have to try 3. We'd have to keep going until you find out that the actual 0, in this case, when I graph it correctly, so I can insert x. There we go, x squared, yep. The actual 0 in this case happens to be at negative 1. Okay, so that would be the guess that I would pick instead of positive 1 if I had my graphing calculator, because it would quite literally tell me my answer. We get negative 1, we got 1, negative 1, negative 10, and negative 8 because the 1 didn't work. You need to have a remainder of 0. Bring down the 1, multiply, negative 1, add, negative 2, multiply, positive 2, add, negative 8, 8, and 0. So it worked with the remainder of 0. That means one of your zeros is negative 1. We have this x squared minus 2x minus 8 left over. Once you get it to an x squared, then from that point, you should factor or quadratic formula, whatever method you know will work. In this case, factoring will work. Multiplying to negative 8 and adding to negative 2 would be negative 4 and positive 2, which means that you have two other zeros that x would equal 4 and negative 2. So we have 3 zeros in total, the negative 1, the 4, and the negative 2. And if you had your graphing calculator, which I kind of quickly took away, negative 1 worked, 4 also worked, and there's the negative 2. Okay? But not every problem will be done completely with the graphing calculator. Sometimes you will have answers that are imaginary or that don't have, like, they're decimals, so the calculator can't do it. Probably going to be the case here on number 2. I'm still going to graph it nonetheless because I don't want to guess 1 and negative 1 and 2 and negative 2. All the factors of 10. Use the technology to your advantage. X to the 4th minus x to the 3rd minus 7x squared. It does take a while to type in though. Plus 5x plus 10. This is not going to tell us every answer, but it will tell us a decent amount of information here. It appears that one of the answers is at negative 1, and the other one probably is at 2. So I'm going to try 2 first because I'm curious about the 2. We got a 1, we got a negative 1, then we got a negative 7, 5, and 10. I'm curious about that 2. It looks like it is, but I'm not certain. So this is a way we can test out if the 2 actually is a 0. 2 times 1 is 2. Add straight down, 1. Multiply. That would be a 5. Add straight down, negative 2. Multiply, negative 4. Add straight down, we get a 1. Multiply, we get a 2. It is not a 0. Ruh-roh. Okay. There is another way you can do it if you do table of values, second graph, table of values. 2 should have worked. Did I type in some things wrong? Y equals x to the 4th minus x to the 3rd minus 7x squared plus 5x plus 10. Graph, okay. 1, negative 1, negative 7, 5, 10. Bring down the 1, multiply, we get 2, add, we get 1, multiply, we get, oh, that's why. 2 times 1 is not 5, that is 2. Add straight down, you're going to get negative 5, multiply, negative 10, add straight down, negative 5 again, multiply, we get negative 10, and 0. Phew! That was a big mess up, I am sorry. Okay, so 2 does work, I thought it would. What you do now, after you get a 0 that works, do not get the next 0 from your calculator, which is negative 1, and divide the original by the negative 1. Whatever you got for your answer from a 0 that worked, that is what the numbers you divide by. So this 1, 1, -5, -5, that's the numbers I'm going to use this go around. Okay? If I do it this time, now I'm going to use the answer I felt more confident with, which was -1. You can choose whatever order you want. I chose 2 first and almost messed up. I did mess up, but I caught it. Bring down the 1. Multiply, you get -1. Add, you get 0. Multiply 0. Add -5. Multiply 5. Add straight down 0. Okay? The 12 wasn't a 12. It was 0, so I didn't include it. So now we're left with, we started with x to the 4th. This would have been x to the 3rd plus 1x squared minus blah, 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 which means this would be x squared plus 0x minus 5. Technically, if we're solving, we're equaling it to 0. So we had -1 worked because it gave us a remainder of 0. We're left with x squared minus 5 equals 0. Once you get it to an x squared, remember you're dividing the x to the 4th, and then you're using that answer, which would be x to the 3rd, and then you're dividing again to get x squared. Set it equal to 0 and solve, which in this case would be plus or minus square root of 5. So we had 4 answers. We had 2, -1, and plus or minus square root of 5 as what the zeros would be. All right, let's move right along. This one, we have a 0 that probably will be a fraction if I had to guess. Let's type it in the calculator to see what fraction to maybe guess at first. We got 2x to the 3rd power plus 3x squared minus 8x minus 12. Graph. Okay, so I'm betting that this is an answer that might be a fraction, the -2, and then something else. And then here it looks very clearly like it goes through at +2. +2 would be one of the possible rational zeros because 12 can divide by 2. So let's try the +2 out. 2, 3, -8, -12. Bring down the 2. 4, 7, 14, don't mess up, 6, 12, and 0. Okay, so we're left with 2x squared plus 7x plus 6, which is factorable. And we multiply 2 and 6 together to get 12. What multiplies to 12 but adds to 7? Well, the multiplying to 12 and adding to 7 would be 4 and 3. So this is going to be x plus 4 and x plus 3. We divide both of these because we multiplied by the 2 in the beginning by the 2. So this is going to be x plus 2 with the technically 2x plus 3. But our zeros would be x equals -2 and x equals, if you change the sign of this one, -3/2. And do not forget the original 2 that we used to get our answer. All right. Last one of the day. I am definitely going to graph it first, but if I wasn't graphing, I would still guess with 1 and -1 first, and then try 3 and -3 before I did 9. The possible rational zeros. The graphing calculator speeds that up, but sometimes not by much. X to the 4th minus 2x to the 3rd plus 10x squared minus 18x plus 9. Graph. Let's look at it. It's swirling. Okay, so this one only has one answer, and it has an answer of at 1, it looks like. All right. So that tells us 2 things. Notice how it's bouncing off the 1. In the next video, we're going to learn that when the graph bounces like this, that it actually is a repeat answer. These possible rational zeros could be repeated. So you could have 2 and another 2, or you could have 3 and another 3, the same exact answer twice. All right, and I recommend writing it twice. That way you're counting up to 4, because you should have an x to the 3rd problem, 1, 2, 3 answers. If you have an x squared, you should have 2 answers. X to the 4 should have 1, 2, 3, 4 answers. So here, the only place it crossed through was the 1. So I'm going to use the 1. I'm going to use the numbers that we have here. And I'm going to divide. Got 1, and we multiply, we get a 1. We add, we get a -1. Multiply, -1, then 9, 9, -9, -9, and 0. Okay? And if you're wondering, Why can't we just divide by the same number every time? If it's not a repeat 0, it won't divide again. So here, if I choose the 1 again, like I'm telling you it's a repeat solution, with these numbers that I have left over, because we started with x to the 4th, now I'm at x to the 3rd, I need to get it down to an x squared, which would only happen on the next go around. If it is a repeat 0, it will get remainder of 0 again. If it's not, it won't. 1 times 1 makes 1, add 0, multiply, not 9, 0, add 9, 9, and then 0. Okay, so we get x squared plus 0x plus 9. I like that remainder of 0, so I can set it equal to 0. So we're really at x squared plus 9 is equal to 0. We're solving here, so we'd need to subtract the 9 and then square root, which ends up being plus or minus 3i. Another thing you may have noticed, which we're going to pay a little more attention to in the next video, is that it only kind of crossed the graph one time, and it should have probably crossed 4 times. So anytime the graph crosses less than it should, as long as they're not repeat solutions type of deal, then you're probably going to have some imaginary answers, which we have here, plus or minus 3i. Then we also had x equals 1, 1 again, and then 3i and negative 3i if you want to list out all 4 for the zeros of the graph. This would be considered all zeros. That would not be considered a rational 0 because 3i would not be considered rational. That's going to do it for this one. Until next time, my friends, stay positive, and I will see y'all later. Bye.